Next is Thiele's U, and here we take the squared sum of the squared errors. Square root of that is in the numerator. The sum of the squared errors of random walk forecast, that's in the denominator. So let's go to Excel. So here we have the squared errors, the sum of squared errors here, and take a square root of that for the numerator. But here we have to take the error from random walk and square that. So here we need to square, so that squared, and you sum that column, okay, like that. Now that's the denominator. Let's put the order back. So that's the denominator. So this is the numerator, that's the denominator. So we need to take a square root of this as the numerator and square root of this as the denominator. So we have square root of that divided by square root of that, and that's Thiele's U. So a number that is greater than 1 means the random walk does better than the forecast that we are considering. A value that is less than 1. So the MAC and U are comparison with respect to random walk, or the most naive forecast that we can think of. Next, we're going to compute the same error measures like before using different forecasting methodologies for that data that we started out with. So if you're going to look at the naive forecast or random walk, okay, which we worked out here, suppose we want the other error measures for random walk. So of course the first forecast is going to be 690, which is given right here. Okay. And for the rest of them, it's going to be just the previous value. Okay. Then we have error actual minus forecast, absolute error, percentage error would be error divided by the actual. Absolute percent error is absolute error divided by the actual, and squared error is error squared. Okay, so now copy that. Now put the border back. So ME is the average of the errors. Okay. MPE is the average of percent error. MAPE is the average of absolute percent error. So these two should be expressed as percentage. Mean absolute error is average of absolute errors, which is also called MAD. MSE is the average of squared errors. Okay. RMSE, root mean square error, is square root of MSE. Okay. Now mean absolute standard error, scaled error, mean absolute scaled error is the sum of absolute errors. So we need the sum here. Okay. Remember, MASE and U are comparison with respect to random walk. So random walk with comparison to random walk is going to be 1, because this will be the sum of the absolute errors divided by the sum of absolute errors. So that will be 1, and here the same thing, it will be square root of that divided by square root of that. So will be 1. Now in the next two tables, one we have a constant monthly average of 1099 as the forecast. Okay, in that case, what will be the errors? And in the last table, we have a constant of 800 as the forecast. Then what are the error measures? Okay, so let's look at the completed. Okay, you do the exact same operations like here. So let's look at the completed table now. Okay, here is the table for monthly average from previous year of 1099. If you use that as a constant forecast for all the 12 months, so these are the error measures that we will get. And now the MASE and U, okay, that would be, you take the sum of the absolute errors of this model, okay, and divide by the sum of the absolute errors of the random walk model. Okay. So that would be the MASE of this, and then for U, will be square root of the sum of squared errors for the current model divided by the square root of the same thing for the random walk model. And that's the Thiel's U for this case. And if you want, and here is the next table where we're using 800 as a constant forecast for all the 12 months. And here again, you take the sum of the absolute errors, divide by the same sum of the absolute errors for the random walk, that's MASE, and take the square root of the sum of the squared errors of the given model divided by the same thing for the random walk model. Make sure that's random walk model. Okay, so that's the Thiel's U. Now in this table, like what's given in your textbook table 2.9, we have arranged the error measures for all of these different models. The last year's value, ME, would be that, right? MPE would be that, and so on like that. If you fill out the table, and this is what it will look like. So now we have all the error measures assembled. So we have mean error and mean percent error. You see that there's quite a bit of bias in all of them. And mean absolute error, mean absolute percent error. Okay, and the percent error also pretty high. And if you look at MASE and U, remember here anything that is greater than 1 means it's doing worse than the naive method or random walk. Random walk would be preferable. So random walk is 1. Anything more than 1 would be worse than random walk. Anything less than 1 would be better than random walk. So last year's values, okay, that gives us better, smaller forecast errors compared to random walk, but having a constant monthly average as your forecast does poorly compared to random walk. Okay. Now let's go to the Word document and look at some of some additional information about these error measures. So mean absolute percent error should be used only when y's are greater than 0. So otherwise we end up with negative values. But MASE and U are not so restricted. Now, MSE measures squared error, and therefore MSE's unit is the square of the actual values. So that's the reason why we take the root mean square or square root of MSE, and that brings the original units back, and the interpretation is more straightforward with RMSE. Now, RMSE gives greater weight to larger absolute errors. The larger tries to decrease the number of larger absolute errors than mean absolute error. Mean absolute error gives kind of equal weightage for all errors. The measure using absolute values are always equal to or exceeds the absolute value of the measures based on the error. So like MAE is always greater than or equal to just ME without taking the absolute value. And MAPE is always greater than or equal to without taking the absolute value. Now MAPE, MASE and U are all scale free, okay, because there is you divide the error by the actual value, and therefore the scale is removed. Now an MASE is greater than 1, then random walk is better. So we discussed that already. And Thiele's U2. Now larger absolute value for ME and MAPE and MPE, okay, either on the actual value being either on the positive side or negative side, suggests bias in the forecast. We already talked about this too.